Alrighty, week 1, part 2, advanced factoring. Fasten your seatbelts. Here we go. So please factor. And when you're factoring, the difficult part is to, recognize what type it is. So here, the cubed indicates to us, hey, maybe this is that sum or difference of perfect cubes. 1,000, we know it's 10 times 10 times 10, and then 1 is 1 times 1 times 1. So I always do this step, right, where I'm writing the thing as something to the third, plus or minus something to the third. And then we're just using that formula with the A's and B's on your notes part 2. So let's see what happened here. 1 plus 10y, yeah, we have 1 minus sign in the formula. 1 squared and then the 10y squared. And again, remember, common mistake is students will forget to square the 10. This is where the 100 comes from. 1 squared is just 1. And there's no 2 in this formula, which is also a common mistake. Alright, so that is done. And this, again, this will look factorable, but it's not. You could try, but okay, question number 1, there we go. Question 2, so look at this crazy stuff. Factoring. And what you're looking for, when you have weird or fractional exponents or roots, what you're basically looking for is you take the variable with the smallest exponent and you pull that outside. So x to the 1/2 is the variable with the smallest exponent that comes outside the parentheses, and then you're just figuring out, okay, this times what gives me 5/2. And so I was thinking, well, 1/2 plus 4/2 equals 5/2. So when we're multiplying bases, we add exponents. So this is this, right? This plus this will give us this. And when we distribute here, we'll end up with this. So this is factored, but this is factorable still, so we're going to keep going. Difference of perfect squares, x squared minus 1 is x minus 1 times x plus 1, and kaboom, there we go. Again, you could always multiply out to double check. So I think we have something similar. Actually, let me not spoil the surprise for you. Alright, so we have fractional exponents. We're starting to freak out, panic. We're going to choose the lowest one. Okay, so number line farthest to the left, we're thinking. Let's pull that outside parentheses and see what happens. So we have x to the negative 3/2, and again we're figuring out what goes here so that we get this. And this is just a 1, that's pretty obvious. But this times what gives us this. So the 2, the coefficient, goes there, but we're thinking x to the what will give us x to the negative 1/2. So again, that was like this. Negative 3/2 plus a positive 2/2 equals negative 1/2. You need your fraction skills on point. So there's 1 here. This is like a 2 over 2. Negative 3 over 2 plus 2 over 2 is negative 1 over 2. And similarly here, we're thinking, because again we're multiplying bases, so we're adding the exponents, negative 3/2 plus something gives us a positive 1/2. And so hopefully you're recognizing that that is a 4/2, which is where this x to the 2 4/2 came from. Voila! And I think, so let's see what happened. Oh, so I rewrote this with, it's common to have the, the squared first, and then the x term, and then the number term. And then I recognize, hey, this looks still factorable, so we're going to keep going. Let's see what happened. Aha! Alright, so our x to the negative 3/2 stays out front, and this becomes x plus 1 times x plus 1. You could also, of course, write this as, oh, hey, I did it right there. Haha. Okay, you could also write it as this. Both are good, same, okay. Alright, next. Factoring. Woo! So, I'm going to try to not spoil the surprise. Remember, we got fractional exponents. We're going to take the smallest or the farthest to the left on the number line, okay, and pull that out. The base is the same. So let's see what that looks like. So we have x minus 1 to the 3/2, and so this times this should give us this. How did I come up with 4 over 2? Let's see. 3 over 2 plus 4 over 2 gives us 7 over 2. We like that. And this times 1 will give us this. There's a minus sign there, of course. So 4 over 2 you recognize as squared. I think in the step down below, which you might want to try on your own, you can put that on pause. This is squared, so we're going to FOIL this out, and then I think there's going to be some simplifying going on. Yeah, so we could rewrite this as squared, a FOILed, multiplied out, expanded, however you want to describe it. And let's see, we end up with minus 2x plus 1 minus 1 cancel out. So we're left with this guy right here, and I think that there's an x common to both of those that we could factor out and get something like this. Crazy, huh? Cool. Okay. So there's some advanced factoring. Let's take a look at page 2. Alright, please factor. So let's see. You see this and you go, what? Chinese. I don't know, maybe you speak Chinese and it would sound like something, look like something more difficult. But a squared minus b squared, so this is something squared minus something else squared. And if you think, well, it's just an a squared minus b squared, you know that if we factor that, we have an a plus b times a minus b. And we could write that as a minus with the a minus b first, either way. So this is factorable like this, so this is going to be factorable like that. Let's see how this looks. So what you just need to investigate, we have a, notice how it's not squared, and then minus b, and then a, and then plus b. Aha! And the cool thing about this is, you know, we're just adding and subtracting. We can basically get rid of the parentheses and a whole bunch of stuff's going to simplify. Like, well, this is plus, and then this will be plus, but we got 1 minus 1. And over here we have 1 over x minus 1 over x, so those will cancel out. So let's see if this is correct. Over here we have 1 minus 1, so those go away, and we have 1 over x minus minus, so plus 1 over x. 1 over x plus 1 over x is 2 1 over x's. That's this. And then over here, this term and this term end up canceling. And we have 1 plus 1, which is 2. So 2 times 2 is 4 times 1 over x is 4 over x. And it's cool when those simplify down to something simple. Not crazy. Number 6, whoops. So this looks like, kind of looks like perfect squares. I'm sorry, sum of perfect cubes is what I meant to say. So if we look at if we think about it like this, so this is x squared cubed, and this is 4 cubed, then we have this sum of perfect cubes. So we're using that formula with the a's and b's. Notes part 2 from week 1. Where our a in this case is x squared and our b in this case is 4. So we have a plus b, a squared minus ab plus b squared. And we simplify and we end up with this. Bueno. Alright, number 7. So first step, if there is something common to all the terms, you factor that out. So we have an x squared common to both of these, and a y to the third common to both of those. That gets factored out. And again, you're thinking, so before you know what those are, this times this gives us this, and this times this gives us this, to figure out what these terms will be. And let's see, x to the fourth, yeah, y to the third, good. We have x squared y to the fifth. Notice how we're adding the exponents. Y to the third, y to the second gives us y to the fifth. So this is factored but not completely. This is still a difference of perfect squares. So we can factor x squared minus y squared to be x plus y times x minus y. And again, we can write it x minus y times x plus y. Same thing. It's all good. Alright, number 8. So this is pretty similar, except instead of the x's and y's we have these binomials. But you see we have one of the terms is x minus 1, so this is to the first, this is to the second. This might help. Write the little ones in there. So we can get x minus 1 to the first, and then here we have x plus 2, and to the first and to the second, so x plus 2 to the first. And if we multiply this times this, we'll end up with this. See how x plus 2 is to the second. And this distributed here gives us this. You see how we have an x minus 1 times an x minus 1, giving us x minus 1 squared. Okay, this can simplify it. We're just adding or subtracting, so get rid of those parentheses. X plus 2 minus x plus 1 gives us a 3. And normally when you just have a number, it should be out front as a coefficient. Looks good. Thank you for listening.